Okay, we will continue with the same slide. Um, um, when we are talking about the long duration gamma ray bursts, their isotropic apparent luminosities are um, in the range of 10 to the power 51 to 10 to the power 52 Hertz per second. But they are actually, unlike supernovae, narrowly beamed. I mean, radiation are beamed along narrow cones of light. Um, so although the apparent luminosities are very large and they last only for a few seconds, the total energies are only around 10 to the power 51 Earth. And this is the prompt emission, um, which is followed by a long-lasting lower energy afterglow. And the afterglow happens in lower in photon energies, lower photon energy compared to gamma rays. And so therefore the afterglow happens successively in X-rays, optical and radio bands. Actually they happen often together, but their duration is shortest often in the X-rays and longest in the radio bands. It's these afterglows which were then, which was discovered, which allowed people to identify host galaxies, because they could then measure and basically they could identify galaxies where these X-rays were taking place, where these gamma ray bursts were taking place, and by measuring line redshifts. Um, uh, Line redshifts are basically redshifts which a line is shifted in wavelength due to the Hubble expansion between the source and the observer. And these host galaxies have turned out to be at very large distances. Even the largest, so far the largest um, galaxy where a gamma ray burst, largest redshift galaxy, um, uh, which is the most distant galaxy in which a gamma ray burst has been seen, is at redshift of 8.3, which was discovered last year by optical astronomers, and they were followed up by radio astronomers. Now, some GRBs are also associated temporarily, meaning in some sort of time window, uh, uh, they are associated with freshly exploded supernovae, and they are also spatially coincident that way. People had worked out models of the fireball, which is launched by this extremely large amount of energy released in a very small uh, volume, and which then had driven shockwave in the through the ejecta of the star that exploded, or the object that exploded, and these shock waves were both ones which ran into the circumstellar or interstellar medium, or were several shock waves which were catching up with each other, because some of the shock waves were at a higher speed compared to the ones which were launched earlier. Uh, the kinetic energy um, of this relativistic outflow, and this is relativistic in the special relativistic sense, this kinetic energy is dissipated, and it's this dissipated energy um, uh, that drives this the energetics of the gamma ray emission. And it's believed that there is an internal engine that drives this relativistic outflow. And the time scales and energetics of the objects that are seen imply that there may have been a black hole formed after the stellar collapse, or a neutron star um, uh, which has merged with another one to form the black hole. And it is these, and it is this central object which is the engine which drives this relativistic outflow that gives rise to this prompt emission, this emission. And GRB's prompt emission are believed to have occurred from the internal dissipation within the flow, whereas GRB's afterglow, which is the long duration, relatively lower energy photons emission, that afterglow is believed to be due to the shock's external interaction with the medium that is surrounding the burst region. There are a pair of rather good reviews which were written by Svi Piran in Reviews of Modern Physics in 2004, and also in Physics Reports in 1999, as well as annual reviews of astronomy and astrophysics published last year by Neil Gehrels, which the people, the interested people amongst you might want to look at some stage. But the fact that relativistic motion is implied in gamma ray bursts was mentioned in print a long time ago, in 1975 by Melvin Ruderman in the 7th Texas Symposium. And this was one of the first mention of relativistic outflow being able to be able to solve the so-called compactness problem.